So today we're going to talk about solving absolute value equations using algebra. First, a little intuitive notion. Absolute value is the distance from zero. So if I were to take and draw a number line, let's do that, and take that number line and go from 0 out to 8, and I say how far or how many units from 0 to 8, we say 8. Likewise, if I put a negative 12 out here on the number line and I count how many units from 0 to negative 12, I get a positive 12. We always think of the absolute value and distance both being a positive value. So if I'm asked to then take and evaluate an expression where I have to substitute, I'll go ahead and do that. So I have 2 times the absolute value of 3 times negative 3 minus 6, close that absolute value, plus 4 times a negative 5. We remember that that absolute value sign is acting like a giant set of parentheses. So I do what's in there first. And there's a multiplication, so that takes precedence over the subtraction. So I have a negative 9, and instead of saying subtracting 6, I'm going to say plus a negative 6. It's all an absolute value. Plus 4 times negative 5 is negative 20. Simplifying the inside of the absolute value, negative 9 and negative 6 is negative 15. How far is negative 15 from 0? That's 15 units away. So I have the absolute value of negative 15 is 15 times 2 plus negative 20. 15 times 2 is 30. 30 plus a negative 20 is a positive 10. Next, we'll actually start using an equation. So this equation asks what values, such that when I take the absolute value of them, I get a 7. In other words, what values are 7 units away from the origin? Well, 7 is simple, but we also have negative 7. So actually, this equation has 2 answers. And one way I like to think about it is if I take the absolute value of whatever's inside, it could be an x, it could be a whole bunch of stuff, that is equal to the plus and minus value of the outside. So in this case, the absolute value of the inside, that's x, is equal to the plus or minus 7. This next problem is kind of a trick. It says, where do I have a distance of negative 10 units from x? We already talked about the absolute value has got to be a positive distance, so this has no solution. Absolute value is equal to positive, never a negative. So let's take a look at an equation, and at the end we'll find its solutions. Here's the inside. Here's the outside. And as I said before, the absolute value of the inside is equal to the positive and negative value of the outside. Well, in this case, I have 2 actual equations that I have to set up. One is x minus 14 is equal to the positive 3. And then the other one is x minus 14 is equal to negative 3. So in this case, if I'm subtracting 14, I do the opposite, which is adding 14 to both sides. I get x equals 17. Or over here, again, I'm going to add 14 to both sides. 14 plus negative 3 is 11. So x equals 11. So I have 2 solutions. 11, 17. You'll notice those are both a total of 3 away from that center number of 14. And if I were to check those out, I have 14 subtracted from 11 in absolute value. That's negative 3. absolute value of negative 3 is 3. Then I have 17 minus 14, which we know an absolute value is 3. The absolute value of 3 is 3. So it all checks out. This problem is really no different. I have an inside, so the inside is equal to the plus and minus value of the outside. Two equations to set up. 9 minus 2x is equal to 33. Or, I know that 9 minus 2x could be equal to negative 33. So I've got a couple of two-step problems I need to solve. This is a positive 9. I'm going to add a negative 9 to both sides. That's going to get me 24 is equal to negative 2x. I can divide by negative 2 to both sides or multiply by negative half. So x equals negative 12. And then on this side again, I'm going to add a negative 9 to both sides. This gets me a total of 42. The negative type is equal to negative 2x. Divide by negative 2 to both sides. I get a positive 21. If I graph that, I have x is 21 and negative 12. Now if I were to say split the difference on the inside, I'd be equidistant from a given point. But let's pop these in. I have 9 minus 2 times negative 12. Absolute value, notice that's 9. Negative times negative is a positive. 24, which is 33. Checks. And then I have 9 minus 2 times 21 in absolute value. That's 9 minus 2 times 21 is 42. 9 plus a negative 42 is equal to a negative 33 in absolute value, and the absolute value of 33 with a negative type is a positive 33. So this all checks. So I look at this and I say, well, here's the inside. That's equal to plus and minus the outside, but notice I've set you up. This says the absolute value of something, and we can say, for that matter, it's a happy face. The absolute value of something there is equal to a negative number. That's never going to happen, so we say right off the bat there's no solution to this, because that absolute value is always got to be positive. Now this problem is a lot different, because you'll notice in all the other problems we had just an absolute value equaling to something. This has a whole series of things attached to the absolute value. The first thing we must do first is isolate the absolute value. In other words, get it by itself. So you'll notice I have a multiplication here and I have an addition here. What I'm going to do is I'm going to add a negative 2 to both sides first, giving me 6 times the absolute value of x plus 7 is equal to 24. I'm going to divide both sides by 6. So I have the absolute value of x plus 7 equaling 4. Now, the inside of the absolute value must equal the plus and minus of the outside. So again, I have two equations to set up. The first, x plus 7 equals 4, or x plus 7 equals negative 4. Add a negative 7 to both sides in this case, and I get negative 3 is equal to x. On the other side, I add a negative 7 again, and in this case I get negative 11 is equal to x. And I can plug that in and I'll get the same answer in each case. But I can't illustrate enough that in order to solve any absolute value equation, you must isolate that absolute value first. Okay, let's read this and we'll go through and solve it after that. It says Taisha uses this elliptical cross trainer at the gym. Goal is to burn 280 calories, but she varies by as much as 25 calories on any given day. And you want to write an equation to find the maximum and minimum number of calories that she burns. So here's the deal. Since I vary 25, it could go 25 high or 25 low. That's like my plus and minus. And that is going to be added or subtracted to her total of 280. And that will give me some value of x. Notice how I'm going to work this backwards. Here's my plus and minus. I got my plus and minus from using some kind of absolute value. So what I'm going to do is take the 280 over to the other side and get x minus 280 equals to plus and minus 25. And then lastly, where'd that plus and minus come from? It came from taking the absolute value of the left side of the equation. So this would be my absolute value equation I use to solve. Notice my answers will be 25 above or below the 280. So my answers are going to be 305 and then 255. And you'll notice that if I compare that with 280, they're 25 above and below. So we kind of work backwards to write those equations. Now I'm going to do the same thing here, and I have to write an absolute value equation where these two numbers are my answers. Now if it's an absolute value, these two numbers float equidistant from a middle point. So if I look at the number 6, I notice that there's 1, 2, 3, 4, 5 to the right of 6 and 5 to the left of 6. So again, if I take and say, well, if I'm 5 to the right and left from that 6, those are going to get my two solutions, one being 1 and one being 11. And if I back that up, I have x minus 6 is equal to plus or minus 5, and that plus or minus, whoops, added those two early, sorry about that, and that plus or minus meant that I have an absolute value. So I have x minus 6 in absolute value is going to equal 5. And if you go through and solve that, you'll get the answers of 1 and 11. So find that midpoint. Here's your midpoint, if you will. Here is the above and below, or equidistant from each side, and then take that number and subtract it over to the other side.